Alright, let's get started with the 12-2 homework for pre-calculus. We'll start with 18, talking about some limits here. So on 18, it says let's find the limit if it exists. So let's see if we can do some factoring here. I'm going to take the numerator, x to the fourth minus 1. That's a difference of perfect squares, so x squared minus 1 and x squared plus 1 in the numerator. And this guy here we can factor again and make x plus 1, x minus 1, x squared plus 1 is still there, and the numerator was always x minus 1. And so at this point we've gotten to the point where we can cancel here, and so if we do the limit as x approaches 1, at this point now we can put 1 in wherever we see x and not have a problem, because before if we put 1 in for x we'd get 0 in the denominator. And that wouldn't work. So let's see here. Plug in 1 here. 1 plus 1 is 2. 1 squared is 1 plus 1 more is 2. So our limit is 4 as x approaches 1. Let's check that graphically and verify that that is indeed the case. So I'm going to swing over to the calculator. And we've got x to the fourth minus 1 over x minus 1. So remember your parentheses. X to the fourth minus 1 divided by x minus 1, and I'm going to take my table and we'll start setting it. Remember, we're taking the limit as we approach 1, so I'm going to go a little bit less than 1. Let's try 0.7, and we'll count by 0.1s. Check out the table. 3.4, 4.6, it looks like we're closing in, and so we could make it a little closer if we really wanted to. To check it, we could even go 0.9 and count by 0.01. And now we'd really see, as we're getting closer to 1, that our values are getting much, much closer to 4, and that's true coming from the other direction. And we can also take a look graphically in our window as x approaches 1, so I'll say between 0 and 2, so that we can see both sides of 1, a little bit to the left of 1, a little bit to the right. And let's change our y's to something appropriate. And let's look at this graph here. So here's 2. I can hit the trace button. I'm sorry, there's 1. Remember, when x is 1, y is not going to work. There's a hole there. We can't have 1 in the denominator. But on either side, 3.8, 4.1, yep, we're definitely approaching 4 from both sides. It's continuous here, except for at when x is 1. Alright, good. So let's keep moving here on to 24. We're going to do the same thing, but this time instead of using some factoring, we're going to multiply by the conjugate here. So our conjugate that we're going to want is roots x plus 4 plus 2, and we're going to do that on the top and the bottom, numerator and denominator. And let's multiply this out. So the square roots are going to cancel. We'll have x plus 4 minus 2 times 2 is 4 all over x plus 4 plus 2, and plus 4 and minus 4 cancels. X and x cancels, and so we're left with 1 over the square root of x plus 4 plus 2. And normally we'd have to clean that up, but really we only care about getting to the point where we can plug in 0 to our denominator. So if I plug in 0 here for x, I'm going to have 1 over the square root of 4, which is 2, plus 2 more gives me 1/4. Okay? And we do need to verify this graphically, so let's plug it into the calculator, make sure it works. Alright, let's be careful with our parentheses here. Square root of x plus 4. I'm going to go double parentheses. Sorry, the square root comes with a parentheses, but there's my second one. So x, I'm sorry, was it plus? Yeah, plus 4. Close it. Minus 2, and then let's close our parentheses so the entire numerator is wrapped up in parentheses, and then we'll divide by x on the bottom. And we'll go to our table, and we're going to be approaching 0. So I'll go a little bit smaller than 0, 0.3, and let's count by 0.1s again. We can always zoom in closer if we need to. Checking the table, 0.25, 0.248. Does that close in on a quarter, 0.25? Absolutely. So it looks like our answer was correct with 1/4, or 0.25. Moving right along, we're doing the same thing here on 30, and on 30 we need to find the limit, all right? And so here we're going to have to go to the table because we're not going to be able to factor anything, and a conjugate is not really going to help us here much at all. It's just going to make things messier. So let's go straight to the table on this. It's what we always can do if we need to. Going to be very careful with our parentheses here. So we've got 1, move this over so we can see both. Parentheses for the entire numerator, parentheses for the first fraction, 1 divided by, parentheses for the x minus 8. Close that, and then close the first fraction. Plus 1/8. Close that, and then close the numerator. All over x. There we go. Let's check our table. We'll start, that's the same thing. So negative 0.3 works. And so looks like we're going to be at negative 0.15, we'll call it 0.156, halfway between the 4 and the 8. So negative 0.156 is what we would write as our answer. Moving right along, 36, same thing. Let's go to the graphing calculator. A lot of calculator work in this chapter. Clear it off. Parentheses for the whole numerator, cosine of x minus 1, close my numerator, divided by sine of x. And before I go to the table, pi over 2, should I be in radians or degrees? Definitely radians. And I am. So I'm good. Let's check my table set. Pi over 2, what the heck is that? Well, let's just punch it in. Pi divided by 2. See if the calculator will let us do that. There it is. It converts it for you. And we're going to be counting by, let's go with 0.01 here. We'll be a little more precise. Go into our table, and so we go a little bit above it. We go a little bit below it, and look what's happening. Negative 1 is definitely our answer. Okay? So negative 1 for 36. 42, let's plug this one in. And sine of 3x over x. Clear it off. Sine of 3x, close my parentheses, over x. I'm already in radians, but I'll check just to make sure. Yep, still radians. Let's check our table set. On this one, we want to be approaching 0. And our values are, what would you say? I would say 3. Looks like we're approaching 3. Okay, and so let's keep moving. 48, same thing, as we're approaching 0 of 1 plus 2x to the 1 over x. Table set for 0. And so we're closing in here on halfway point, 7.54 and 7.24. So we're going to add them up and divide those by 2. And if we do that right, halfway between 2 and, let's see, 24 and 54 is 78. Half of 78 is 39. So we're going to have 7.39 as our answer on 48. All right, 54 explicitly asks us to do the things we've already been doing. It really wants us to look at this graphically using the trace and the table and using the conjugate method. Since this is already up, I'm going to go start with C, part C, and do the conjugate here, just because we already have it. X plus 2 plus root 2. Top and bottom. And so we're going to have x plus 2 minus 2 all over x plus 2 plus root 2. And this does what the conjugates want us to do, cancel things left and right. So we'll have 1 over, and instead of x, let's plug in 0. Which gets us 1 over 2 root 2. Can't have roots on the bottom. Multiply, and we'll get root 2 over 2 times 2 is 4. And what is rad 2 divided by 4? Let's go to the calculator and check. Square root of 2 divided by 4. 0.3535 is what we're looking for. So let's remember that number, and let's plug this into our y1. Clear this off. All right, again, 2 parentheses. 1 for the numerator and 1 for the first square root, which comes with a parenthesis, so x plus 2 minus root 2. Close your parentheses. We're done with the numerator, all divided by x. All right, we're closing in on 0, so negative 0.3. And in this case, notice the little negative here. We only care about coming from the negative numbers. So when we go to the table, we don't care about anything down here at all. Even though they might work, don't care about them. We only care about 0 from the negative. So 0.35, 0.35, 0.35. Was that what we were looking for? Yeah, it certainly was. So verified by the table, so that's part B. And how about by the graph? Let's check the window. Let's go negative 1 to 1, so we're centered on 0. And graph it. Really small, I can't really see what's going on here, so let's zoom in. Go with the zoom fit to adjust our y values. There we go. And let's go to the trace. X is 0, we don't have a y value, we know that. Let's go a little bit to the left. 0.35, again, that's what we're looking for. So it's verified 3 ways: graphically, with the table, and also algebraically here. 3 ways we can confirm our answer. Alright, so 60, let's talk about the limit if we have 2 different one-sided limits. So this, when we go towards 1, something's happening to the left when we're less than 1, and something different is happening to the right when we're greater than 1. Can still use the graphing calculator. We're just going to use piecewise functions on this. So piecewise, we got to get the whole thing in parentheses, 2x plus 1. Even though it normally wouldn't need parentheses, we need to put it in so that we can put our parameters. X is less than 1. Close our parentheses, and we'll go down to y2, which is 4 minus x squared. And this is going to be for x greater than or equal to 1. Close that parentheses. All right, so we're going to graph both of them, and we're going to approach 1. So let's go to the graph, set our window up first. I'm going to go from 0 to 2. Let's go a little bit lower than that. How about negative 1 to 3? So we have a couple on either side. And probably going to want bigger y values than this. We'll go negative 10 to 10. Can always zoom in from there. So there's the first piece. And then there's the second piece. If your graphing calculator isn't doing this, remember in mode you have to change your... Oh, mine actually worked. A lot of times you need to be in dot mode instead of connected mode. If it worked, great. If not, you try changing that and see if it works. Alright, so trace as we are zooming in on 1. Looks like we're going to get 3. And then we go to the other one. What happened here? We need to be on the other equation. Notice we're on y2. Got to jump up to y1 if we're to the left. And so as we close in on 1, we're closing in on 3 as well. So our limit here is 3. You can also check that by just, if we plug in 1, which function are we going to land on? Equal to 1 is the bottom one, so we can plug it in here. 4 minus 1 squared is 4 minus 1 equals 3. Okay. We can also, jumping back here, look at the table. As we approach 1, change my table set. .4, 2.6, 2.8, our next guess would be 3, but then we're going to ignore these because we don't care about y1 once we get to 1. We care about y2, and so if we go this way, notice here we do hit 3 exactly at 1, so it works out. Alright, 66, absolute value of x, cosine x. Clear this off, let me get rid of y2 as well. Absolute value is in math, there it is over in num. Cosine x. And we are going to be approaching 0 here. It says also let's graph x and negative x. So we're going to plug in x, we're going to plug in negative x, and I'm going to change my window here from negative 10 to 10 as well. Just as a good starting point. And let's see what happens. There's my initial function. There's x, and there's negative x. Look what's happened. We're bounded inside of negative x and positive x. Okay, so just wanted to, the textbook wanted you to see that. And what happens is we're approaching 0 here. As we close in on 0, it looks like we're getting to 0. Let's do a box zoom here, just to really get in there. Around 0. Really see what's happening in there. Alright, so we are in there, and we're hitting 0 on this one. Trace, let's make sure we're on y1. As we close in for x is 0, y value is really close to 0. So the limit there is 0. Make sure you get the graph on there. 72. All right, let's do the derivative here. All right, so 3 minus 4x goes in for our first f of x plus h. So it's 3 minus 4. Instead of x, we're going to put x plus h minus, put both of these in parentheses, 3 minus 4x all over h. Let's clean it up. 3 minus 4x minus 4h minus 3 plus 4x all over h. What cancels? 3 minus 3 does. Negative 4x and positive 4x does. H and h cancels. Our answer is negative 4. Okay? So on this one, we don't even need to plug in 0 for h because all of the h's have gone away. So our answer there is negative 4. All right, that's it. That's all the even problems for the homework. Any questions? We'll check them out in class.